Welcome to part 3 of the Modular NOC series. In this video, you're going to learn about how to add constraint files, or XDCs, to the design that define connectivity and quality of service parameters for each individual NOC connection. To refresh your memory, the Modular NOC solution is comprised of 3 main steps. Step 1 is to connect all AXI buses that want to utilize the NOC to Xilinx Parameterizable Macros, or XPMs. The second step of the process is to add constraint files, or XDCs, to the design that define connectivity and quality of service parameters for each individual NOC connection. And the final step is to run the validate NOC command. In this video, we'll focus on the second step. Step 2 of the modular NOC flow is to add constraint files, or XDCs, to the design that define connectivity and quality of service parameters for each individual NOC connection. We will be making connections to the XPMs that were added in Step 1. The XDC constraint file can be specified per module and does not require the RTL to be elaborated when modified. Looking at the file, the first 2 lines of this file store the NMU and NSU instances into Tcl variables. These are given paths to NMU and NSU instances. In this manner, the command can be applied to the NMU and NSUs contained in either the XPM modules in RTL or the NOC IP in the block design. It does not matter how the NMU or NSUs are added to your design. In the example we've been describing, the NMU would be in the XPM module connected to the DMA in the RTL, and the NSU would be contained in the DDR memory controller within the NOC IP instance on the BD. The next line defines the addressing aperture of the NSU. The base address and range is used by the NOC compiler to ensure that all addresses contained within this aperture are routed to the appropriate NSU. Note that if the NSU is located in the block design, the aperture of the NSU is defined in the BD and would not need to be specified in the XDC constraint file. The next line creates a NOC connection between the NMU and the NSU and stores it to a variable called NOCCon0. Finally, the setProperty command provides all the QoS properties related to the connection. With this XDC, we've found the NMUs and NSUs in the design, created connections between them, and applied the QoS constraints to those connections. Fairly straightforward. We introduced this design in the previous video. Now we'll have to create the connections between the RTL-PL NOC master and the BD-based DDR-MC NSU, as well as make connections between the AXIS M/N interfaces. The connections that need to be created in the XDC file are represented by the red line shown here. Once the XPMs are added in the design, we need to create an XDC file so that we can create connections between the NMUs and NSUs and specify properties for those connections. To start, from the Design Sources window, click the Add Sources icon and then select Add or Create Constraints. Then click Next and select the Create File option. Specify the file name as NOC Constraints. Click OK, and then Finish. A new XDC file, NOCConstraints.xdc, has been created and added to the Sources window. Once the NOC constraints file is created, set the UsedIn property of that file to Synthesis Pre. This is necessary for the validate NOC command to find the NOC constraints. Now we can open the XDC file in the Vivado text editor and specify the endpoints, connections, and properties. As a first step of creating the connections, we can use the Get NOC Interfaces command to get a list of available NOC interfaces in the design. First, we will create the connection from the RTL-PL NOC master to the BD-based DDR NOC NSU. For that, copy the PL master to the DDR-NMU interface and define it to the variable NMU to DDR. Now, copy the DDRMC NSU and define it to the variable DDRMC NSU. Next, use the create NOC connection command with the source as NMU to DDR, target it to DDRMC NSU, and define it to the variable con0. This completes the connection of the PL to the DDR NSU. Next, we need to create the connections for the AXIS M/N interfaces. Copy the NMU interface of the XPM instance 0 and specify it as PL AXIS NMU 0. Similarly, we'll copy the NMU interface of the XPM instance 1 and specify it as PL AXIS NMU 1. We'll do the same for the NSU interfaces for both XPM instances 0 and 1 and specify those as PL AXIS NSU 0 and PL AXIS NSU 1 respectively. We'll then use the create NOC connection command to create the connections between the two PL AXIS NMU and two PL AXIS NSU instances. So now, in total, we've created 4 connections for AXIS M by N. Going further, we need to specify the properties for the connections. We can use the setProperty command to specify the read bandwidth, read average burst, write bandwidth, and write average burst for the CON0 connection. That is, the connection from the RTL-PL NOC to the BD-based DDR NOC NSU. Similarly, we can use the setProperty command to specify the TDEST IDs for the AXIS M by N NSUs. If we need to set the apertures, we can use the setProperty command. As the properties are now specified, we can save the XDC file. To recap this video, we've demonstrated creating an XDC file, including specifying the used-in property for the XDC file. We've illustrated how to use the output of the getNOC interfaces command when creating the endpoints. We've also shown how to create the connections between the NSUs and NMUs, as well as how to specify the QoS properties and the TDEST IDs for the connections. The next video in this series will demonstrate how to use the validate NOC command.